Okay, now we know from the last couple of videos how to calculate the area of a triangle when we have the interior angles. There is a less well-known formula for calculating the area of a triangle, which is the easiest formula to use when we don't have any of the angles inside. So if we have a triangle like this one, we know it's not right angled, we don't know what any of these angles are, but we know what all the side lengths are, which I've labelled here A, B, and C. So we have a formula for calculating the area of this triangle. A little bit of background, developed by a guy whose name was actually Heron, and he lived about 2,000 years ago in the city of Alexandria in Egypt. And true to his name, he was the first person who invented a vending machine. He had a little thing that did pretty much the same thing that a modern day vending machine does, and he was the first person to invent that. So there you go. But the other thing that is more important for our purposes that he invented is this way of calculating the area of a triangle. And it relies on this thing that we label with an S, S standing for semi-perimeter, or half of the perimeter. So S, the semi-perimeter, is half of the perimeter of a triangle. So if the side lengths are A, B, and C, then half of the perimeter is going to be A plus B plus C divided by 2. So that's this thing S. Once we have the value of the semi-perimeter of S, then we have the formula for the area of a triangle, which is the square root of S multiplied by S minus one of the side lengths, say A, multiplied by S minus another one of the side lengths, B, multiplied by S minus the last side length, C. So this here is the formula for the area of a triangle when I have the 3 side lengths and none of the angles inside. Heron's formula. We won't come across it a lot, but it's important to know in this course. It will come up a couple of times, and it's good to remember. Let's do a quick example of it. So here's a triangle. It's got side lengths of 7 centimeters, 5 centimeters, and 10 centimeters. So if I want to calculate the area of this, the first thing I have to do is work out what the semi-perimeter S is. So it's going to be 7 plus 5 plus 10 divided by 2. 7 plus 5 is 12. 12 plus 10 is 22. So that's 22 divided by 2, which is 11. So half the perimeter, the semi-perimeter, is 11 centimeters. The area is then the square root of 11 multiplied by 11 minus 7 multiplied by 11 minus 5 multiplied by 11 minus 10. Now, of course, I could stick that whole thing straight into my calculator, and if you're using your class pad and you can see really clearly what you're doing, then that would be probably the easiest and best way to do it. But just to kind of step you through it to make sure that we will understand how this is going to work, I'm going to kind of do it step by step. So first, let's work out what each of the things in the brackets are. So that's going to equal the square root of 11 times 11 minus 7 is 4, times 11 minus 5 is 6, times 11 minus 10 is 1. Now 11 times 4 times 6 times 1 gives me 264. So the area of this triangle is the square root of 264. And if I put that into my calculator, the square root of 264 equals 16.25. So the area of this triangle is 16.25 centimeters squared. Like I said, this isn't something that's going to come up super often in this course, but it will come up and is important to know how to use this formula, Heron's formula, for the area of a triangle when I have the 3 side lengths and none of the angles inside.